Cool. Mhm. Okay, awesome. Thank you, Love Thing and Matchbox Style for having me today. Um, Today I'll be introducing the Starklink VRF, and um, if for those that are not familiar, a VRF is a on-chain primitive that's used to get secure random numbers onto the blockchain. So uh, at Starklink, we have deployed our own VRF, both to the testnet and mainnet. And we made a few modifications to from the sort of the spec that's used in Ethereum ecosystem to make it work with uh, Starknet. And today we're going to be um, using the on-chain randomness oracle in a sort of a test game. So what this workshop's all about is requesting and receiving a random number from the Starklink randomness oracle. So there is a document that highlights all the steps that we're going to be doing today. So if that's your kind of preferred way um, of doing this sort of tutorial, that's great because as we'll see, we're going to be deploying to the testnet, and the block times are a little slow for kind of like a real-time thing. So we might kind of be jumping around to different contracts that have already been deployed just to save time for this live audience. So the first thing we're going to do to deploy our game is we're going to clone the VRF Starknet repo. So let's go and do that. We'll need Cairo language, of course, and then also the Nile, Cairo Nile toolchain, because that's what we'll be using to deploy our game. So before we deploy our game, let's quickly look at what we're going to be deploying. So sort of the base contract that we have, that any contract that wants to use our Oracle will contain is this RNG consumer contract, and there's a few variables here that we can quickly go over. We have an Oracle address, which is the smart contract address of our Oracle contract. So that's what we'll be using to call in the request RNG method. And then another thing that we're going to include in our request RNG call is a beacon address. And this is used to register beacons at the Oracle contract for collecting fees, essentially. Basically, you need the Oracle itself is sort of this transparent coordinator of RNG requests to different beacons, and then the beacons themselves sort of receive a fee if there would be one in the future. Currently, there are no fees, so this is not something that's super important, especially on testnet, where we're able to serve RNG requests at this time for free. And so that's sort of the request RNG is pretty straightforward. And then the last function we're going to have is the will receive RNG function, and this is going to be what is called by the oracle once it itself receives and verifies the RNG. They will call this will receive RNG function, and we will first of all check that only the oracle that we specified can call this function successfully, and then secondly, we're going to do something with that RNG, and we already have a smart contract that does something with that RNG, and that's our example dice contract. And as you can see in this will receive RNG external function, we receive our RNG, which comes in this big int3 structure, and then we call this roll dice function that essentially from this larger number we get a number between 1 and 6 and then store that information into a stored variable. So we're going to be deploying this dice contract here, and to do that, let me first activate my Python environment that has our kind of Cairo and whatnot. Is we have these Nile deploy contracts for both the Oracle and the dice contract. Today we're going to be using the dice contract script. And so here we need to specify our Oracle address and beacon address. Is anyone following along, by the way? Just so maybe I can just keep track, or is everyone here just sort of watching passively? Right. I'm just gonna assume people are watching passively, which is great, because we're gonna be like deploying and making transactions, and that might take a little bit of time. So the first thing we need to do is update these. Yeah, that's cool. I also probably think people just have like more generic questions or like so much about they're currently no one's like really deploying a game contract right now, so this is more probably informational. But so I updated the Oracle and beacon address according to the document, and we're going to run a command to first of all compile our dice contract. These are all specified in the document, so these should be straightforward. And then we're going to run our deploy script to the Goerli testnet. Then shortly we should receive information in here. So what this Goerli deployment specifies is the address that this contract's being deployed to. It's not necessarily deployed yet. And if we go to our blockchain explorer, we won't see that this contract is deployed for a few minutes. So what I did just before this call is I deployed 37 minutes ago this same contract. And we'll see in the write contract methods, there is the request RNG, or the request RNG method. And we need to be logged into ArginX for this step here. We're going to request RNG for our game. So you can kind of think of this request RNG method being called in like a RPG game when there's like a mischance in a game where you're looting a character and there's like different loot drop rates. Um, and so let's call this request RNG function here. And you should see and keep an eye on this pending transaction activity in your Arginx wallet. So what I'd like to do is jump forward in time again to the result of this when this transaction gets seen and verified by Starknet. Um, and briefly, this is what sort of the inner workings of the VRF is doing. Is it's querying for blocks on the Guerrilla testnet in this case, and looking for an event emitted by your request RNG transaction, and then it here it in this kind of blurb that's probably not very legible, uses a private key to perform a cryptographic procedure to generate a random number based on this like deterministic input that you give it, and then it requests the callback method to verify that random number on chain, and then send it over back to the dice contract. And once our VRF receives the random request, processes it, sends it back to the Oracle, and then the Oracle sends the random number to the our dice contract by calling will receive RNG. You'll see another event emitted in the dice contract, and here we can see kind of the end result of this whole procedure. This event shows us that the random number that our dice contract ultimately received is this number here, which I believe is like a 172-bit number. So these are broken up into limbs, with the highest order limb being 0. The request ID that we had for our given dice roll here was the 5th one. So if you're keeping track of dice rolls and you didn't want someone to, or particularly you didn't want the Oracle to sort of call back the will receive RNG function twice with the same request ID, is you would invalidate this request using this ID parameter. And the result of this dice roll is 2. So if we did, I think, a mod 5 on this and then added 1, yeah, we would get the result of 2. So this, dice roll could then be saved or used to produce a further result if the game was some sort of wagering game or something like that. And so that's sort of the tutorial that I've laid out for you guys today. We learned how to deploy a game or a smart contract that interacts with our Oracle and then produces a random number that the game can use. So with that said, do folks have comments or questions that I could answer? Cool. And so there is kind of another workshop that I'm working on where I can we plan on decentralizing the Oracle and its fee mechanism. And so in another tutorial, I'll show you guys how to sort of um, connect to the Oracle, set up cryptographic software in the cloud, and then you can yourself create and verify random numbers for the Oracle, which I think is another interesting aspect to this project. I'm going to stop sharing.
I just had a quick question.
Sure thing.
Is obviously Empiric Network have also launched their VRF. I haven't actually familiarized myself with how they're doing it. Is there quite a few similarities? Are they launching it to be decentralized in the future?
Yeah, so I went to their sort of presentation on the their VRF that they're working on, and I've also talked briefly with the main developer, Rob. So I'm not entirely sure about their plans on how whether it's just the Empiric organization that is going to be responsible for creating beacons, or if they're going to be more permissionless about it. I do. I have told him that I think the best approach is probably collaborating on this because they're using a similar spec, and I honestly actually think that they're probably going to be more or less forking the code that I'm using for the verification. They don't have that yet, so I think we'll probably have a similar VRF and probably collaborate on servicing requests together. That's my hope. But it'll depend on what the Empiric network decides. I'm not sure about their business model, other than the fact that I think they're making a VRF because they feel like they're obligated to, as like a quote unquote Oracle network, um, compared to um, me and my team. We're really trying to make the best VRF for Starknet as possible. So we'll see how things develop there.
Cool, sounds really good.
Yeah, thank you for the question. Great. Thank you everyone for coming. I appreciate everyone that could attend in person. Blue Thing, do you want to kind of send us off, or maybe something? Mm-hmm. Mm-hmm. Sure thing. Great. Thank you, everyone. Sounds good.
Bye.
See ya.
Bye, guys.